Hello everyone, welcome back. In this lecture, we are going to solve this problem of developments. In which what we have to do is we have to draw the lateral surface of a truncated vertical cylinder, which is 40 mm in diameter and height is 50 mm. The main condition is the truncated flat surface of this vertical cylinder bisect the axial height at 60 degree to it. So let's start with this problem. So here we will start with if we have vertical cylinder, so in top view we will have this circle which is of 40 mm diameter. Okay, starting with this circle. Now change it to the main drawing. Again going to draw one line. Later we will use a polar array command to divide the circle in 8 equal parts. So just select this thing. Now press Control and polar array. Okay, use this array polar command. Now provide the center. This is the center. So by default, it will divide the circle into 6 equal parts because it is the default setting in which we have 6 items. Now you can change the number of items. Usually we use 8 equal parts. We need to convert this. We need to divide this circle into 8 equal parts. So we'll go to this items here. Now you can see here it is by default it is 6. So we are going to make it 8. Now press enter. So now you can see the circle has been divided into 8 equal parts. Now just provide the naming to these 8 equal divisions. These are in top view. The circle is in top view, so we will use only small letters. So here I'm using alphabets. You can also use numerals if you want. So this is our top view of the vertical cylinder which is resting on HP. Now from this top view we have to generate our front view. As in the question it is given, the vertical cylinder is of 50 mm height. So just from this top view we will try to generate our front view. So these are the construction line. These two are on the same line, so we will use only one line. This is our center line through which we will draw our axial height, which is 50 mm. Again, these 2 points are on the same vertical line, and this is the individual corner. So now here we will draw our front view. So what we can do is draw horizontal line first. Now extend this line or draw a new line from this point up to this. Again do the same process for this one. Now you can remove the excess ones. These are the extra lines which you need to remove before we move any further. Provide a single line here. Now you can change these lines to the main drawing. Okay, so this is our front view of the vertical cylinder which is resting on HP. Now what we need to do is we need to, if you look into the question, it has been asked the truncated flat surface of the cylinder. So after truncation by the truncation plane, after this circle get truncated by the plane, the truncated surface, the remaining surface of this circle, the top surface of this circle makes an angle of it is bisecting the axis. It means that it is dividing this axis into equal parts, or you can say simply that flat surface is passing through the midpoint and as well as makes an angle of 60 degree to the axis. So you need to draw a line which will pass through the midpoint and makes an angle of 60 degree with this vertical axis. So if this angle it's if you want this angle to be 60, then from the horizontal remaining angle will be of 30. So just do one thing. Draw an inclined line which should be at an angle of 30 degree. So this angle is 30 degree. With the HP we have 30 degree angle, and then you can say this remaining angle is at 60 degree. So because we need to draw this line such that this line makes an angle of 60 degree with the axis, and this line is bisecting this axis, means it is passing through the midpoint. So this axis is divided into two equal parts. Now just remove this angle here. Now you can remove this axis line and just do one thing. Select this, move it to the main drawing. Now extend this line in the backward direction up to the left extreme point. So this is the truncation plane, or you can say this is the truncated flat surface which is bisecting this axis, means it is dividing it into two equal parts and also makes an angle of 60 degree with this axis. So now this is the leftover part and this is the truncated part. So we will remove this thing. To show this removed body, we will just draw construction line over it. So it will look like this part has been removed from the body. Okay. Okay, so this is the truncated part, and we are the bottom portion is the leftover part after the truncation. So now you have to draw the lateral surface of this truncated vertical cylinder. Initially, if we have a vertical cylinder, then if you open this cylinder circular body from this point, then we will have a straight line here. If we open up this circle from this point, then we will have a straight line here, and height we have this much height. So overall you can say after the lateral surface of this vertical cylinder is a rectangle, and the length or this horizontal distance of that rectangle should be the circumference of the circle. And you very well know the circumference is 2 pi r, or simply pi d, pi into the diameter of the circle. So just convert this thing into multiply pi with this diameter, you will get the circumference or this horizontal length of the cylinder. And height, we know this vertical cylinder is of 50 mm height, so our rectangle will be 50 mm by pi into d. Okay, so the length of this rectangle will become 125.6, which means multiplying the circumference of the circle is 3.14 pi into diameter 40, so it will become 125.6. and we have divided the circle into 8 equal parts. So we have to, each arc will after opening this up, the circle in a straight surface, you will get a rectangle. And similarly, you can say complete circle will provide a big in lateral surface form. This complete circle, after opening it up from this point, it will give a big rectangle of which length is of 125.6 mm and height is of 50 mm. So you can say this arc, after opening this arc, we will get a small rectangle. So the length of this small rectangle will be 125.6 divided by 8, or you can simply say circumference 1/8 of the circumference, because these arc are of equal length and they are in 8 equal parts. So we will do just one thing. The total circumference is 125.6, and to get this arc length, we will divide the circumference by 8 and we will get this arc length. So this arc length is 15.7, and height, we already have the height of 50 mm. So we'll draw a small circle, a small rectangle, and we need 8 rectangle of this length. So we will just make a first rectangle here, of which height is 50 mm and length is 15.7. Then we will just make 8 copies of this rectangle. Just type this one. First point is here. Now we need to provide the dimension. So in dimension, first we will provide the 15.7 length and then enter height, which is 50 mm. Now direction is in the upward direction. I'm placing it on the same axis on which our this vertical cylinder is resting. So I'm putting this on the reference line. So this is our this is the lateral surface of the single arc, or this from A to B arc, and to the this is lengthwise, and in terms of its height, you can say this is the first small lateral surface of this arc. Now this, as we know, the circle is divided into 8 equal parts. So what we will do, just make 8 equal copies or 8 copies of this small rectangle. Here you can just provide the width of this thing or length, which is 15.7, 1/8 of the circumference, and this height, as you know, this one is 50 mm in height. So just mark them, and now we have to make 8 copies of the small rectangle. Just make okay. While making the copies, just select the reference point, this one, and put it here. So we'll have a second rectangle which is just attached to this wall. So in the same way, you can create 8 copies. So 4, 5, 6, 7, and 8. So now we have 8 equal parts or 8 structures. You can name them. This one is we are going to start from this point A. So this will be A to B. First arc is A to B. So just mark them. This one is A, and the second point is B here. Similarly, you can mark each of the point. Second arc is B to C. Third one is C to D. Then E, F, G, and this one is GH. So this is our second last step, G to H, and last one is H to A. So H will repeat one more time. So and if we revolve this thing, these lateral surface, so this will come again to this point. So it will coincide, this line will coincide with this one. So we will have only 8 arcs or 8 lateral surfaces. So this is the primary lateral surface of the vertical cylinder, and out of this lateral surface, we have to develop this truncated body, lateral surface of this truncated body. So what we will do, just do this thing. A, you can see A is here. This is the A edge. Now either you can just mark them here, and you can put here, or just relate this these edges with the top view. Now in the A, you can see this one is A. A is at this much distance. You can either measure this distance. First thing is just measure this distance. So this surface at this edge A is truncated at this 13.5 mm from the base. So while doing in the sheets manually, you can do one thing. From this point, measure the length, which is 13.5 mm. So in A, from the base, from this point, take the compass of 13.5 mm radius and take this point, this intersection as a center. Now create an arc which will intersect here at a distance of 13.5 mm. Or simply you can do one thing, just from this point into this truncated point, draw a horizontal line which will intersect with this line. Both will represent the same thing, because this this point is at a distance of 13.5 mm from the base. So we are drawing a parallel line which is parallel to this one, this base. So this distance from base to this intersection is equal to this distance. Both are of same length. So the simplest thing we can do is we can draw horizontal lines. So similarly, we can do the same process for each point. So this represents point B, and from this line B, you have to make a horizontal line which will intersect with this B. Now follow the same thing for rest of the points. This is C, so this is our point C, here to C here. Now this is point D, from here to D, from E, draw a line up to the point E. Now again F will lie on the same line on which we have this D. So we can extend this line from here, but it will create some confusion here. So we will do just one thing. I'm going to mark these lines first. So from here to here, first point is up to here. This one is C, and this is point E. Now what I'm going to do is I'm going to extend this line because this is the same line on which we have D, and right now in this step we will have F on the same line. So we will, you can see here D and F are on the same line. So again here D and F will be on the same line. So just what we can do is just extend this line up to the F. Now follow the same thing for this one. Again G will be on this line. So extend this line up to the G. Okay, and this one here H. So we have to extend this line up to the H. Now again the last point is A. So you just extend this line up to the A. So we have, so now just connect these points like this. Okay, now you don't need these construction lines anymore, so you can just remove these lines. Now this is the developed surface, or you can say the lateral surface of this truncated vertical cylinder. But here is the main thing which you need to be considered very carefully. If this is a solid part like a prism or a pyramid, you will have straight faces, but this is a vertical cylinder. So if you truncate this body, instead of the solid flat surfaces or flat lines, there will be a curved structure because this is the circular part. So in this profile, instead of this straight lines, we will have a curved profile. So here to draw the curve, in manual drawing you can draw the curve in multiple points. Start with this one with the help of protector, but here instead of creating arc with the help of arc command, you can just do one thing. Within this draw, on the left side you will get a command which is spline fit. Use this command to create a single curvature. So start with this point, first click, second, just change it to the main drawing first. Now use the spline fit command, left side, and start with this one, first, second, third, attach all the point in a single segment. No need to press escape or anything, just click these points continuously. Now this is the last point. So after that, just touch it a little bit. Now instead of pressing enter escape, just click right click and press enter. Now we will have a continuous curve. So now this is the bottom part which is of straight line. So just going to draw this again. Now this is our truncated, the lateral surface of truncated vertical cylinder. So this is our solution. Now just remove the construction line from the inside portion. Now you can see this is a okay. Just select these straight lines and remove them first. Then these lines need to be removed. Okay, so these are just used for the so that we may not get confused over here. So that is why we have used these straight lines. So this is our lateral surface of the truncated vertical cylinder. So this is our solution. The height of this cylinder initial is 50 mm and the diameter is 40 mm. So this is our solution. Okay, thank you.